Dear students, continuation to the previous topic, memory management. So, logical address space versus physical address space. So, the concept of logical address space that is bound to a separate physical address space is central to proper memory management. Concept of logical address space that is bound to a separate physical address space is central to proper memory management. So what is logical address space and what is physical address space? Logical address space. So it is generated by the CPU and also it is referred to as virtual address. Logical address is also called as virtual address. Remember this. Physical address. So physical address is seen by the memory unit. Generally, whatever the address is there, the physically, that is physical address. Okay. Logical and physical address are the same in compile time and load time. In compile time and load time, logical address and physical address are same, and it is having binding scheme also same. But logical or virtual and physical address are differ at execution time. When coming to the execution time, it is different, right? Logical address space. Logical address space is a set of all logical addresses generated by a program, and physical address space is set of all physical addresses generated by a program. Memory management unit, MMU, memory management unit. Hardware devices, hardware device that are runtime maps virtual to physical address. Every time virtual to physical address, it will be mapped. To start, consider simple scheme where the value in the relocation register is added to every address generated by the user process at the time it's sent to memory. So base register, now called as relocation register. Remember that base register will be called as relocation register. And MS-DOS on Intel 8086 used 4 relocation registers. MS-DOS has used 4 relocation registers. The user program deals with logical addresses. It never sees the real physical addresses. Execution time binding occurs when reference is made to location in memory. Logical address bound to the physical address. Logical address will be bound to the physical address. So you can check with this memory management unit diagram. This is a CPU. CPU will send the logical address, the address of 346. Relocation register for all the addresses, it will add 14,000, right? So it will become, the physical address will become 14,346. This is 346 and this is 4,000. Both will be added and that will be your physical address. That physical address will be stored in your memory. Dynamic relocation using a relocation register. Routine is not loaded until it is called. So better memory space utilization in the dynamic relocation, and it is unused. Routine is never loaded. So all routines you may call it as set of sequence of instructions. Routines kept on disk in a relocatable load format. And it is useful when large amount of code are needed to handle infrequently occurring cases. and no special support. No special support from the operating system is required, and it is implemented through program design, and OS can be provided, providing libraries to implement dynamic loading. So this is in the previous slide diagram. Again, we can see here memory management unit. Coming to next one, dynamic linking. Dynamic linking. So static linking, dynamic linking. What is static linking? So system libraries and program code combined by the loader into binary program image, that is called as static linking. Dynamic linking. So linking postponed until the execution time. When the execution time is arrived, then the linking will be done. That is called as dynamic linking. So small piece of code, generally small piece of code called as stubs, it is used to locate appropriate memory resident library routine. So stub replaces itself with address of the routine and execute the routine. So operating system checks if routine is in process memory address. If it is not in the memory address, then the address space, it will be added to the address space. Dynamic linking is particularly useful in libraries, and these systems are also called as shared libraries. So we can consider applicability to patch system libraries, and for that version is also required.